Bryan Nelson, a senior lecturer from UMT. Dr. Bryan has a decade-long training as a bioecologist who has explored oviparous spawning biology through sediment incubation and now ventures to decipher the horseshoe crab's resilience in the habitat and in the presence of coastal communities. Currently, he's drafting criteria to appoint citizen scientists. This bottom-up management is effective for horseshoe crab conservation because bycatch assessment, illegal trade, and sea ranching practices, as well as habitat restoration, are community-led programs. And I hand over the floor to you.
Thank you very much, Mr. Harris and Mr. Muti, for the introduction. I'm not sure whether everyone here has encountered about horseshoe crab before, because even when I give talks abroad also, not many people know what are horseshoe crabs. So we will begin with an introduction, but it will be a crash course. Not too much details. Just join me and have fun. So I will begin first with the slides. Okay. Is it clear, Mr. Harris? Is it clear?
Yes, it's clear, but maybe you can put it into slide mode, presentation mode.
Dr. Bryan, may I just interrupt for one
Yep.
second?
Yeah.
Yeah, to all our listeners, as normal, we will have a short quiz after this presentation. And of course, as always, there will be prizes. So get your kids ready, get your pens and pencils, notes, and write down, all right? Thank you very much.
Begin with the crash course. Horseshoe crabs are actually visible only when we see them. Let's say, for example, when you go to the beach, it has to be a full moon night. When you just walk along the beach, you'll be able to see them. It'll be like a gray color object moving, usually in pairs. And then along with that, when you pick up one individual, you just carry it in your hand. Usually you don't carry it by the tail, you have to hold the body itself. So when you carry the body up, it depends on which way that you're holding it. Either you're looking at it without not having its legs exposed to you, or the other way around. So these are the two appearances that you will see. And usually people will distinguish horseshoe crabs based on their a very simple morphology, where the larger one is always the female, the smaller one is always the male. But regardless the area or the population, the male sometimes grow a little bit enlarged that they appear almost similar to the female, or the female is too small that it appears similar to the male. So when we come to those kind of situations, usually the first criteria we look up is to identify which type of horseshoe crab it is. So over here you're seeing the image of Carcinoscopus because the tail is smooth. So if we will get on to that later on. So based on this classification, we are able to say whether we are looking at a different species or we are looking at a different gender. So these are the common traits that we use. So we will look at it with its feet here, and then we will flip, and then we'll look at the carapace. So this way, if you look at it, will be called the prosoma view. This way you flip, it's called the carapace view. So this way is like the image on the left, and this way will be the image on the right. Okay. So the basic differences, we will get down to the basics first. So where are horseshoe crabs classed? They are not crabs, although they are known as a crab. Crab is a decapod having 10 functional legs, whereas for the horseshoe crab, despite having 10 functional legs, the first 2 legs are used for feeding. So they are appearing in very small sizes. So the closest relative of horseshoe crab would be the images on the right hand side. So you have ticks, you have spiders, you have scorpions, and you also have a different category of animals known as small, what you call it, sea lice. So when we look at horseshoe crabs, we need to know firstly that they are not crabs. They are not having calcium carbonate structure. Their structure is comprising of um, chitosan, and also difference when we try to extract what do you call this, their surface, you will be able to retrieve some chitin. So not to be confused between flexible, whereas keratin is a bit tough. Okay, so that is on the morphology part. So the horseshoe crabs are classed under Ziphozura, okay, along the same classes with all the other animals that are appearing with segmented bodies. So the three segments. So although they are known as cephalopods, they have three major components, which is the carapace, as this way you see the carapace. Then there's a bendable structure, and this hard part is known as the sorry, we will get back to the opistosoma and in another explanation. So the bendable is the opistosoma. Then we will get on to the calcium. Okay, so these are the ultrastructures. Very similar way how you want to distinguish between each of the horseshoe crabs. Okay, in this slide. So when we want to do the morphological sectioning, usually we will have either 6-point morphology, where we will include the prosomal width, the prosomal length, the interorbit length, the opistosoma length, and the Telson length. There is some confusion between the carapace length and taking into account the total length, because when you look at carapace length, you are differentiating between the genders, whether that horseshoe crab is able to carry a lot of eggs, or it is usually known as a brooder. So when they are matured, when you flip them over, the upper hinge of the prosoma, so we'll be looking at the image on the right when you flip them over. So you'll see that pointed end. So it is in between those pointed ends that you're having the eggs. Okay, and then for the male, that's where the sperm is stored. So during the reproduction, that sac is emptied right until the middle section. Right before you see, if you see the image on the right, you're able to see 5 arrows. So the leftmost arrow is where we have the most toughest muscle of the horseshoe crab, where it's able to bend the tail. The second arrow is where you're going to look at the book gills. Okay, so when you look at the right until the rightmost book gill, that is the genital operculum. So it is at that section where the eggs are being released. So we will go on to the next one to distinguish all the other species of horseshoe crabs. It's a very simple process. All you have to do is practice. So you have a bunch of horseshoe crabs. Asia, we have 3. America is only 1 exclusive species. So if you look at um, the various forms of horseshoe crab, the body shape, you are able to roughly tell which species you're handling. Of course, if you're handling the tridentatus, which is the largest one, that will mean that you're taking samples from Borneo. But if you're looking at Gygas and Carcinoscopus rotundicauda, then there is probability that these samples are from Peninsular Malaysia. Okay? Because Peninsular Malaysia only has 2 species. So when we look at how are we going to distinguish them, usually we will look at the carapace. So carapace shape is given up as above, the margin. So that will be the frontal margin. Then we will flip the horseshoe crab this way, and we will look at how the structure would be. Okay, so that's the carapace front. And then we will look at the pedipalp. So when we flip it over like this, so it's having its legs. So we'll be looking at the pedipalp structure, and then we will be looking at this component to distinguish between the male and the female. And then to differentiate the species, we will look at a Telson. So I was mentioning earlier that we are looking at a rounded Telson. So Telson is the tail. So if the horseshoe crab is having a rounded tail, it would mean that we are looking at a Cassinoscopus rotundicauda. And then if we are having a triangle tail, it could be one of the other three. So the tail that is very sharp and having spines on it, that would mean that we are having a gygas. If we are having a tail that is slightly bent but more extensive and thick, that will mean the tridentatus. We are not having limulus polyphemus in Asia, but if a person would attain a horseshoe crab from the United States, that would definitely be a polyphemus. And then the genital operculum is where earlier I showed the rightmost book gill. Okay, the second arrow, the rightmost book gill, that is the genital operculum. So when a horseshoe crab matures, there's another way how to distinguish the male and female. So the male one would be having a sharp triangular-like structure, whereas the female one will be a more rounded structure. So this form of identification we usually use when we are dealing with horseshoe crabs that are very small in size, and it will be difficult to examine their appendage. So we will just flip the genital operculum, and then from there we will identify them. And then the last one is the opisthosomal margins. But not to be confused, the females that are newly matured, they will have very beautiful spines. Okay, and then the moment that they start mating, that is where the spines start breaking, because the male horseshoe crab will collapse on it. Okay, the first appendage is like the shape is like it will follow the female. So the moment the male clamps on it, there might be a tendency that it's going to break spines. Okay, especially when one appendage is getting detached and then it has to come back again. So in that process, it's going to entangle between the spines and eventually it'll break. And female horseshoe crabs that are actively mating, one will notice that their first three spines are very beautiful. The last three spines, those are the ones that are very vulnerable to be broken. So horseshoe crabs that have taken a pause in the mating, one will notice that the spines do come back, but in a very broken, rounded shape. Okay, it will never be a long spine anymore. It'll just be a round piece. And then if the horseshoe crab is actively mating, that will be a hole. It will be like a gap, like this C shape. So those are the indications that horseshoe crabs are actively mating or they have taken a pause. So the range of horseshoe crabs, as I mentioned earlier, we have horseshoe crabs in the United States and we have horseshoe crab in Asia. So Asia, we have 3 species. United States, we have 1 species, as indicated in this image. So there are cases where certain islands are recording all 3 species, especially between the Palawan Islands and the Sulu Sea. So those islands, there are chances to entangle all 3, whereas as we get southward, the chances to get Tridentatus and Tachypus gigas is much more frequent than getting Cassinoscopus. So the reason is depending on the area that we examine. So in Asia, we have our data updated very properly for Tachypus tridentatus. But for gigas and Cassinoscopus, there's so much room that we need to explore and it remains unexplored. The reason is because we continue surveying the same locations and we continue updating those populations by neglecting the other areas that we have yet to examine. So this is in Peninsular Malaysia. So in Peninsular Malaysia, one will notice that the most literature has come out is from Cerating, Balok, Gelang Patah, Johor, Pulau Indah, and also Kolas Petang. But in terms of survey effort, there are other places yet to be explored. And some of them that we have documented in an article, which was a review article in 2018, we produced. So over there, we have mentioned that we have updated the map. And in that map, it's a global distribution for Asia. Okay, so throughout Southeast Asia, there are other countries that are coming up with literature. So recently, we have data for Indonesia, and we also have data for Myanmar. So that's a good breakthrough for horseshoe crab research, and we hope to update the statuses of Cassinoscopus rotati cauda as well as Tachypus gigas. So now we will get to the technical part. How do we actually differentiate horseshoe crabs in your area? So when one goes to an estuary, one would encounter the Tachypus gigas emerging adjacent areas adjacent to the open sea. And it will be occasionally that we find Cassinoscopus laying their eggs over there, where usually Cassinoscopus eggs are towards the mangrove area. So that is why Cassinoscopus has been known as the mangrove horseshoe crab. So Tachypus gigas is usually known as the coastal horseshoe crab. So it's in areas where you get sediment almost the same as what we will get in the shores that lie adjacent to the open sea. So there will be whitish, and sediment texture is a little bit coarse, close to fine. Whereas for Cassinoscopus, it's usually mud-laden environment. So over here, in this description, we will show that the conditions the eggs have to go through, and it is this deciding factor that determines the location of the nest on the shore. So usually we have the high tide, the mid tide, and the low tide. So the location on the shore will tell us whether that environment is still a good environment or not for the horseshoe crab to come. So when they usually spawn at the highest tide level and the nest is deep, that would tell us the area is still fine. But if the nest is shallow, shallow would mean 4 cm. The most shallow that I find is around 3.5 to 2.9 cm. And the most deep nest that I found is around 13 cm. So these are the indicators to say that sediment, that area is having the sediment that is preferred by the horseshoe crab. And then there will be conditions where there will be a tide rise and a tide fall, and there will be period of temperature shock to the eggs. So that is where egg incubation matters. So for the horseshoe crab to hatch out, it is a hatchling. And horseshoe crab hatching out is triggered usually by the lunar phase. So horseshoe crabs and the lunar cycle, meaning the Earth cycle, the moon cycle, on occasion, which is 15 days, but there are some between 14 days to 16 days. So based on this cycle, the horseshoe crab comes to spawn, the eggs develop, and then hatching period is determined coinciding to those period. So a good cycle would mean 30 days, a bad cycle would mean longer periods. So when the horseshoe crabs hatch out, they just swim along because they still have the yolk until they first molt. The moment when they first molted, then they will start searching for food. So this is a brief cycle. Now the next thing is the factors that determine the horseshoe crab that come to an area. Site selection, that's the right term. So when they come to that area, what are the factors that influence them to come there and lay their eggs? In these loose packing sediments, when one steps on it, if we step on it, it's bound to leave a depression. But if the sediment is tightly packed, when we step on it, we just leave a footprint, but it's not going to have a depth. So those kind of areas, horseshoe crabs very rarely come and visit. And when they visit, they usually dig. Okay, if they find the area unsuitable, they will just move on to another place. But if the area is suitable, they continue their digging, and there will be bubble formation. So usually when we examine horseshoe crabs, during the spawning season, we will look for the signs of the bubble. So areas that are having bubble, we will leave a place mark there so that we'll come back and visit that site later to examine how much of eggs did it lay. And that information is so important that it can tell us whether that habitat is going to be there's going to be a future for that habitat as a nursery ground to support young horseshoe crab or not. Okay. Now, image A and image B, the differences are the placement of structures. So when we place structures that are near water movement, it's going to create a structure which is having a lot of bed load, meaning that the bottom sediment is going to start piling up. Okay, so when this happens, the water current is going to become bigger when it hits the structure, and eventually it will be further and further and further. Okay, but when monsoon comes, it will move like this. So it's going to start clearing, and then there will be erosion. So eventually, we are getting horseshoe crab nests at the beginning of the year. Towards the end of the year, that area is not going to be suitable. So barriers, windbreakers, wave breakers, those are not suitable structures when there is contact of water. But when they are away from water, it actually benefits the oviparous animals. Oviparous animals are like horseshoe crab, turtles, crocodiles. So these structures actually assist them because they rely strongly on the area that they lay their eggs for the incubation, meaning that the substrate, sediment acts as a substrate. That substrate provides incubation to the horseshoe crab. So this was a very important study for all horseshoe crab researchers, where Brown and Barnum investigated the structure of the egg when fertilization takes place. So they observe the first cleavage, second cleavage, and the molting. So in this process, it tells us whether the fertilization it's going to be successful or not. So when we learn about the fertilization of horseshoe crab, we discovered that the amount of exposure to sperm would have a certain time frame. Okay? And it is within this time frame where the cleavage takes place. If there's no cleavage of the eggs taking place, meaning that the chances for the eggs to continue developing will cease or may slow down, and that can lead to a longer or delayed hatching period. So, in this study, became the fundamental for the other researches that take place. Okay, so in the next research, we look at the duration for the eggs to hatch. So in this study we carried out at the laboratory, the eggs are constantly in an aquarium provided with sufficient aeration. The only problem is there was no thermal shock. So we acquired the eggs that were taken from day one, newly fertilized, and we continued rearing them until they hatched out. And what we noticed is instead of having 30 days, they were having 43 days. So the importance of thermal shock should not be ignored. It is very important. So meaning that it's only the beach condition is suitable for the horseshoe crab to develop the horseshoe crab embryogenesis. If we remove them and we put them in a laboratory, this process is going to take longer. And imagine if a delayed embryogenesis happens, are we going to get horseshoe crabs that are going to continue remaining healthy as they are? Okay, this is something for us to think about in the future. So these are colleagues that has been working with me for a very long time, and if it's not for them, a lot of our assessments would not be successful. So I would always appreciate each of their expertise and their opinions, and together we have formed a very, very strong team. And beginning first, we did an examination on how fishermen would like to would catch their horseshoe crabs. So we tried to identify, is it a reason because they have the technique? Is it a reason because they knew the environment, or is it because it brings good value to them? So in this breakdown, we observe that it's actually um, not that important. The reason is because of demand, and the success of them catching it would rely strongly on how much the request is. If they are requested to catch 50 horseshoe crab, they would take the effort to catch 50 horseshoe crab. If the request is for 100 horseshoe crab, then they would do that. But there are also fishermen who cast an ordinary gill net, which is around 4.0 to 4.5 inch, and it's meant to catch fish. But horseshoe crabs become entangled. So when that happens, the horseshoe crab becomes a bycatch, and we only notice that the female is being removed, whereas the male is being returned back to the sea. So what happens to this female? They remove the female, they clean the female, either they sell them at the market or they are sold to a trader which comes from very far away, and that trader brings this horseshoe crab to that place. We are not sure whether it is across the border or it is to a different state. We are yet to examine that. But let's forget about that. The main aim here of this study is to find out and see whether are they taking both the pairs or it's only just the female. And what we found out was the female crab was more sought by everyone. So those that are consuming the horseshoe crab, they would prefer the female. So it is the same in the crab industry, where aquaculture produces male and female, but people buy the female because it has eggs. So the price of the female increases, whereas the price of the male remains the same. And in this case, for horseshoe crab, it's the same thing. The price keeps escalating because of the female, whereas the male, there is a discounted rate or there's a bargain. So one would buy 2, 3 crabs or maybe more, and then they will get it cheaper. But for the female, it is sold exclusively for that fixed price, no discount. So different forms of strategy were employed. So we observed Johor, Malacca, as well as Pahang, and we observe that there are catch laws, okay, and these catch laws are strongly held by the community. So meaning that they observe it strictly. On that day, there is no fishing, meaning that the fisheries resources take rest, and then it proceeds on the following day. So the most important knowledge by far that we have extracted from the community is the use of 8-inch gill net. So this catches both genders. Whereas if they use a smaller size, it will catch either a male, or if the female is solitary, then they will catch a female. Now, horseshoe crab females and males, when they are solitary, it is very easily to identify them. They have mating scars on them, meaning that they have mated. So they have mating scars. Okay. So this would be the head. This would be the head. This would be the opistosoma, and this would be the talson over here. Okay. Just imagine the talson is present here. So now, when they have mating scars, there will be marks here and sometimes over here. Okay, but when they stop mating, this place, because the carapace has been exposed to weathering, barnacles tend to attach. So there's a slime community that comes, then there's encrusting. So that is a sign that they are no longer actively reproducing. They have remained dormant. They don't move around as much as they used to, and they are old, meaning that they are old horseshoe crabs. So they only move around to consume food, and then they remain at that place. So when there is a lunar period taking place, they will join in crabs, and then when the net is there, they will catch either the male or the female, and as individual and not as a pair. Okay, so horseshoe crabs are only coming into as pairs during the high tide, and it must be lunar period. Then only they come in together as a pair. In deeper waters, they're always a single crab, unless we catch them in shallow water and they are solitary, so they will have encrusting on them. So the knowledge that we extracted from fishermen is the 8-inch net, and this 8-inch net is very effective if we are only targeting to catch horseshoe crabs. So we appreciate local knowledge, and we use this local knowledge to find out to develop our citizen scientists. So citizen scientist would mean has expertise on knowing about the crab's behavior, the crab's biology, when is the spawning period, when is it time to cast the nets. So using this knowledge, we appreciate it as traditional ecological knowledge, and they are as good as a scientist. Like I would consider every one of us as scientists, okay, because we are part of community, we understand about science. So they are as good as scientists. The only thing is they do not have the certification to qualify them as a scientist. So using citizen scientists, we are learning and creating a method to evaluate them so that they get the certificate. Now, why is it very important for them? So that they can become the voice of the community, meaning that either they assist us with awareness programs or they teach other people, okay, about marine life or marine animals. So this is what we are looking, the value of our study. So these are the examples, and then we extracted this knowledge and constructed a principal component analysis. And what we noticed that these individuals were having knowledge on seasonal, meaning that they know when is the horseshoe crab going to come and spawn. Okay, so we would class that as a bycatch. So when the horseshoe crabs are coming to spawn, that would be cockle season or mussel season. So they are going there to catch the cockles and mussels, but they're getting horseshoe crab. So we classify that as a bycatch. And then they know that horseshoe crab catches a high price. Okay, so high price would mean not the local market, not those who consume horseshoe crabs, but people who take the live horseshoe crabs and transport them elsewhere. So they are paying higher price than the local market. And also, age is very important because age is a very close relationship with experience. So having weightage on this, the overall that we found out that the fishermen know their environment, they study on their environment. Only thing is they feel inferior with us, okay? Because they feel that they do not know how to explain about the environment in the most simplest form, and they are afraid of us because when we come there, we speak a higher language. Actually, it's no. If we know how to speak to fishermen, we come down to their level, we communicate with them on the same wavelength, we are able to extract the knowledge that we somewhat may know, may not know, but they know about their environment because they are staying there. Okay? So we did a small study lasting roughly around 4 years. So what we notice is the fishermen, they learn along the way, okay? And then if we suggest something, they know it is for the benefit of their resources. So in return, we are taking the benefit for our horseshoe crabs. So we did a small study and we requested them to carry out some management measures. So proper boat docking, um, construction of area to dump their waste. So that area is the only area where the nets are discarded if not needed, and then somebody comes in, collects it, and recycles it. Okay, it's plastic. It can be hard plastic, soft plastic. It can be wood. It can be paper. It can be anything. But it became a small place where they temporarily hold this thing and not throw back into the sea. So the benefit they saw was the whole area having a recovery. Okay, and along with that process, they also saw that the return of their resources that they wanted. So it always takes practice and observation, and everything is a learning process. If we continue to go to our environment and then we create some disturbance, we know that disturbance, if it's continuous, it's going to create an impact. But if we can reverse this process by implementing some of the scientific knowledge that we acquired from reading, and then some scientific knowledge that we acquired from the community. when we integrate them together, we will know that there will be a success story. So this is how we are trying to adopt our citizen scientist approach. So these are brief notes. What have they acquired? Uh, we noticed that the horseshoe crab embryogenesis, as I mentioned earlier, you see, 28 to 30 days, meaning that within 2 cycles of the lunar period, we are getting hatching. So these are the things that we like, and these are the success stories that we appreciate, and we continue to empower the fishermen every time. But we do not neglect on our approach because we have personal objectives where we want to see a species to recover. But we use this organism as a tool. We do not 100% focus on them. Because when you 100% focus on them, you are neglecting other resources. But when you include other resources, everything within the cycle, everything restores back naturally. Okay, so these are forms of damage that have occurred. We have lost horseshoe crab spawning grounds, especially in Pekan. Bauxite mining was taking place. The impact was at the area of study, as I showed earlier. In Pendas, we are also having developments where they reclaim land, constructed their own land area, and built on it. So that is creating impact to Gelang Patah as well as the area of Pendas. So over there, we are not able to run this project because the community over there are scattered. They are not in one community or one area only. Okay, so when they are scattered, it is very difficult to reach to communication, meaning that everybody has an opinion and everybody has a suggestion. So the only way that we can work around this is to have a success story in Pahang and slowly spread our word around Pahang. Okay, so this year I will be implementing that. I have requested for some scientific approaches that we can use to initiate this, but the COVID situation came. So once that relaxes, then our next approach is to bring the success stories to all the other fishermen around Pahang. And these fishermen are the ones who are going to be the voice. So our job is just to coordinate, but they tell their success, what is happening. So we also learned that horseshoe crabs can be consumed with other marine animals. So this is one species where if a person would consume Cassionococcus, okay, as its own, add it together with alcohol or coffee or durian, the chances for poisoning is very high. So Cassionococcus carries a little dose of tetrodotoxin, but this fisherman found a way how to reduce the toxin. So meaning that when he consumes the horseshoe crab, he also is able to eat durian and is also able to drink coffee. Okay, so his technique is by combining it with the blue swimming crab, and that the gills of the crab absorb whatever toxins they are, and once the cooking is done, the gills are removed and discarded. So it is a tedious process, but over the years, local knowledge has helped enable communities enjoy the food that they like. So these are the stories that we really love. We not only love to listen, but we also love to explore. So throughout Malaysia, there are 14 states, two municipals. So within the 14 states, we are able to extract some knowledge, especially the states from the coastal. Whereas most of the older generations, um, they move towards urban areas, and when they do that, they lose their local knowledge. So these are the communities that have chose to remain there. And when we went to explore, we learned from them. So this is Liu. As you can observe, these are the crabs that have been taken away by traders. Okay, meaning that these are crabs that are going to be distributed elsewhere. So There are different ways how to tackle situation. The old form of conservation technique would be awareness. The new form of conservation would be also awareness, but in a different approach. Okay, so meaning that we, instead of informing, we are now practicing. So the only way to reach a good form of practice is to work with people. And it is not the scientific community that has to implement and suggest to stakeholders, but it is the community that should say that they are having a problem. This is our knowledge, and this is what we have learned. So it is our job to take what they have learned, combine it with our knowledge, and suggest to them that try different approaches to solve their problem. So by doing that, we are able to reach a common success story where resources are preserved and there's no what do you call this, horseshoe crabs are not under impact. So while we are waiting for their statuses to get updated to ICN, they are still remaining. Tachypus gagas and Carcinoscopus is still listed as data deficient. So while we are waiting for that status to change, of course, we have to produce the report to get that change. So while we are waiting for that, we are also observing that horseshoe crab numbers are declining. So the only way to decline is to carry out an effort at where they exist. So by practicing good management practices, we can reduce the impact. And by the time we get sufficient data, we have enough samples or enough wild stock to say that this is how much we have left. Okay, and we are going to continue protecting them. So the first one is nesting sites. We have only explored a handful, there are more to explore. Number two is we want to establish a protected area. But it is very difficult to get a protected area because you need to find who owns the land. Okay, so the best way is the community that uses the land, they are having the power to protect. So meaning that they want to protect their resources, their importance, because that is their bread and butter. So this is where the citizen scientist was implemented. The third one is to explore on other species. Yeah, we have the Tridentators, we have the Carcinoscopus, but Tridentators is only available in Borneo. Carcinoscopus remains neglected because it is small in size, there is less importance, and it has the tetrodotoxin. The Gygas does not have this issue. And then the last one is the most challenging is because we have development projects. There was EIA carried out, but horseshoe crabs remain neglected because there was no sightings of them in that area. As I mentioned earlier, it takes the lunar cycle to bring them into shallow water, and they are only visible during the spawning season, unless we put nets and we capture them. So in usual circumstances, when they carry out EIA, they will look at the fisheries importance, they will look at the community importance, but oviparous organisms are always neglected. So to know more about horseshoe crab, we have a toolbox. So this toolbox has every single knowledge from Southeast Asia, Asia, and America. So do feel free to explore, learn more about it, especially if you're keen on history, you're keen on conservation practices, you're keen on guidelines. This will be a good site to learn from. These are the available literature for further reading. Every 4 years, our group in IUCN will produce books that contains various works of researchers, various forms of opinions, updating current studies. So we will publish them in Springer. So downloading these as an ebook would benefit rather more than buying the hard version because the hard copy is a bit expensive. But overall, reading this would tell a timeline what were the strategies that were taken to revive back the species. Okay? So most of the literature is for the American limulus, whereas the Asian one is slowly kicking up. We have very good workers or very good researchers in Hong Kong, led by WWF and also Ocean Park. And also we have researchers from Seneca, Taiwan University. They're also doing an extremely good job on the conservation effort. Along with that, this is the last slide. So horseshoe crab has been around us. If one has not seen it, one will definitely know what a Pokemon is. So taking on the forms, creating plush toys from horseshoe crab is a plush toy which is unattractive. So they have taken a different way on how to tell that what are horseshoe crabs, what are their abilities, what are their strengths. So wrapping up the whole thing, horseshoe crabs are living fossils. They age older than T-Rex or known dinosaurs, and they are segmented like the centipede. They have segments, so they are segmented, and they are sort of the oldest existing animals on the planet. So why not we continue looking after them instead of causing more trouble to them, because they only rely on ground to continue producing, meaning that they put their eggs there. Otherwise, they do not cause any harm to us, but we cause harm to them by bleeding them. So that will be the picture on the left hand side on the bottom. So we have bleeding labs where now there's a measure to say that there is a sustainable practice in bleeding, but the accurate information remains questionable. So with this, thank you very much.
All right, Dr. Bryan, thank you very much. Very informative and very knowledgeable information you've shared with us from the morphology, from the issues, from the efforts from the community, how they can help to sustain the conservation of the social crabs. All right, next we will go to the Q&A as well as the quiz. So everyone, I will put up the link to the quiz in the chat box. You can start the quiz in a moment. And Budi, you can take over for the Q&A session.
Thank you, Harris. Okay, the prizes, okay, sponsored by Dr. Bryan Nelson from University Malaysia, Terengganu. Okay, we have this coloring book. We have 4 of these. Okay, and then we have this one is the number 1 prize is basically a sketchbook on the animals. Okay, thank you, Dr. Bryan. So questions, let me just open up, which is, what is the color of the horseshoe crab blood? Dr. Bryan?
Can I have all the questions related to the blood? Then
yes. Okay. Is it true that horseshoe crab blood are being milked by the pharmaceutical industry in the USA for its medicinal properties? If it's true, what are the lifespan of the crabs being used for this industry as opposed to their natural lifespan? Okay. Is there a similar practice in Malaysia? That's it regarding to milking of or the blood of it. Yes.
Thank you very much, Mr. Woody. So question 1 would be, what's the color? So the color would be a very light blue. When you puncture the horseshoe crab, you will notice that there's a small leakage that comes out, but by the time it exposes to air, it will be like a jelly. Okay, so if you continue puncturing, so the jelly, the hole of course gets bigger, so the jelly also starts leaking out. Okay, so it will push the jelly, okay, as it coagulates. So this is a form of natural coagulation, and it is because of this that horseshoe crab blood has gained importance. So in the milking industry, where they bleed the horseshoe crab, okay, but the safe bleeding of horseshoe crab would be the size and weight of it. So we are trying to get the right mathematical formulations to solve that issue first. So once we have managed to solve that, then we can know accurately every single horseshoe crab how much of quantity blood that is supposed to be drawn. But at the moment, they are playing around between 250 and 300 ml of blood. Okay, and the survival of the crab with 50 ml of blood is uncertain. Some of them say the horseshoe crab once fed, and then after a few weeks of rest, then it's continue going for bleeding. It's no issue. But some of them say they are bled to death. Okay? And I've seen in my own eyes bleeding going on. The horseshoe crab looks fine. It was only 150 ml. After 2 to 3 days, there was some infection and the horseshoe crab died. Okay? That's in front of my own eyes. Okay? But at the field, what do we do is when we bleed the horseshoe crab, especially for identification, because we are trying to establish a repository together with the help of Dr. Akbar, where we are anyone who is requesting to identify horseshoe crabs or any forms of property within their blood or gill tissue would have to come and pay a visit to our repository. So once they apply to us, we will provide them with a sample. And this way, we actually bypass a lot of difficult legislation measures because we are not dealing with live samples. And our samples are preserved and processed, and they are not going to cause any form of contamination, especially by bacterial contamination. So back to bleeding. The coagulation happens when it's exposed to air because of the bacteria. Okay, and horseshoe crab blood is blue. So when you get a good quantity, okay, even collecting it in a syringe, you need to add in heparin. Okay? Once you add in heparin, then you remain it as liquid. But without heparin, there's no liquid. It's just jelly. So there's no point bleeding it and causing harm unless your job is to do some sort of research on them. But you must remember when you do the puncture, you must always do it with caution. So horseshoe crabs, when you keep them anywhere flat, they will always turn like this. So over here, they have a muscle. Okay, so it is this muscle that we puncture, and before we puncture, we always take the same caution like before we take an injection. We will always swab it with alcohol. So we clean the surface. We take the same procedure by applying pressure, holding onto it until the bleeding stops. Okay, the horseshoe crab becomes straightened up like this, and then we remove the swab. So once we notice there's no more coagulation, it means there is no more harm to the horseshoe crab. Okay? So when we've done our studies, we are taking that into consideration, and we are using always the finest needle. Okay, when we draw the blood, it takes practice. So what do is we practice on dead samples. Okay, so when we practice on dead samples, it is hard. It's very tough. But that allows us to control our puncture, meaning that the amount of pressure that we apply. So using that practice over time, then only we worked on the live samples. So when we got on the live samples, it's much easier to puncture. So we roughly know how much deep we need, the depth that we need. Okay, so we put that point and we hold, we draw, and done. So to do that, it takes a lot of caution and a lot of practice. It is not simply a person can take a syringe and draw the blood. Does that answer all questions?
Yes. The other one related to this would be, aren't these medicinal ingredients reproducible chemically rather than taking from the live horseshoe crab?
Okay. Currently, our medical industry is advanced. I must say, yes, there are a lot of replacements like recombinant C factor. Unfortunately, because it takes time to get these things approved, so they still rely on the primitive method or the primitive approach. But horseshoe crab blood use is not like I would say every single horseshoe crab blood is being used immediately. It's a certain batch they will test a random number, use this endotoxin testing kit, and then certify to say whether this medical equipment is safe or not. So meaning that this batch produced using the same, meaning within the same time or the same material is safe to use. But once there is contamination, then this whole batch is discarded. So that blood, when it's produced into this endotoxin testing kit, would be a produced by a company that is following a certain form of guidelines. Okay, and there are laws and enactments carried out to make sure that this form of exploitation doesn't uh, reach to a level where we can say that it's causing harm to the horseshoe crab. So from now, this is the strength that we have. But the genuinity and the practices of the company, we are not sure. Because one is the demand is large. And then number two, testing takes time. So we are challenged by that.
What do they use it for, doctor? What's the purpose?
Okay, like say every medical equipment to check whether it is sterile, they will use an endotoxin testing kit. So that's where horseshoe crab blood comes in. So they would test and see whether there's any coagulation taking place. The moment there is coagulation, meaning that there is contamination. Yeah. Otherwise, medical equipment are not sterile.
Okay, understand. A couple quick questions. Where are these horseshoe crabs exported to? Okay, first one. Secondly, do different species mate together? So you mentioned 2 species in Malaysia, right? Do they mate cross interbreed?
Okay. The first question regarding the export, I think in this presentation it is not good to talk about it. But I would say yes, the border, across the border, there are some activities going on. Even across the states, there are some activities going on. But we cannot take any action because horseshoe crabs that are involved, they are still remaining as data deficient. So until we update the statuses, then only we have certain reason to say, yes, we have to stop this practice. Okay. So what are they used when they go across? That I can tell you. When they go across, yes, they are being consumed, but before they are consumed, they are bled to death. So meaning that it's a win-win situation for the supplier. It's a win-win situation for the person drawing the blood as well as the person who is in the meat. So
Yeah,
the next question.
Yeah, do different species mate together?
Yeah. The second question, so far I've never seen Tachypus gigas mating with the Cassionoscopus, nor gigas mating with the Tridentatus. But I have seen an overlap, meaning that Cassionoscopus is latching on a female gigas. Okay? But I've never seen the product of this, because when we go to the nest, when every single nest that we dig, we are noticing that when we get green or green yellow eggs, those are Tachypus gigas, and when we get yellow and also deep yellow eggs, those are Cassionoscopus. And the area that we are getting the eggs are also different. If areas that are upstream, we are getting Cassionoscopus. Areas that are downstream, we are getting the gigas. So I've never seen cross species happening, but I have seen uh, uh, the attachment of 2 different species together. So why does that happen? It could be when they were caught by the fishermen are playing a fool with them and releasing them that way. Okay, or it could be a confusion between the male and the female, meaning that they are disoriented, meaning that they came to actually spawn. So opportunistic mating took place, but unfortunately, the amount of sample size to produce these claims are insufficient, because by far the amount that I've seen is only 2 pairs. Yeah.
Okay, one last question. The others we have to leave it, okay, because we're running out of time. Why did you decide to go into the field of horseshoe crab? Okay.
Okay. Horseshoe crabs did not attract me. It was just because there was an offer to do further research on them. So I took up to learn about their biology. Then I somehow found that they can be applied because they go across 2 environments, which is the water environment and the land environment. So that allowed me to explore other things. So I'm only using them as a tool or as an excuse to do research. But now I use them as an indicator. So if I do not know their biology, I would not be successfully using them to the fullest advantage. I will still be focusing on looking after horseshoe crabs and their conservation. But because I can apply their biology to turtles, to crocodiles, to horseshoe crabs, then I can look at different forms of environmental damage and the impact to these indicated species because of their life cycle. Adults are in the water, the juveniles, sorry, not juveniles, the embryogenesis takes place on land. It has to be on land. So if we know that we are not getting embryogenesis occurring on the land, we know that the land is having some issue and that area is no longer suitable.
Okay, I understand. Thank you. That comes to the end of the Q&A. Harris, over to you for the results. Thank you.
All right. Thank you very much. Let's share the results of the quiz. All right, here we can see we got three winners. You can omit the first three on top because those are us testing the quiz. So first to come in is Paula Ng, second is E. Swinyo, and third Mitran Kartikeyan. So congratulations to the three of you. All right, two more prizes. Okay, we got Adrian and we got Karina Kartikeyan. All right, so the five of you wins. All right, congratulations to the five of you.
So I believe that the five winners understood all the essential questions that were asked, and they also understood the biology of horseshoe crab. So my question to them is, would these winners partake on as future horseshoe crab researchers, or are they keen to be conservationists, or are they keen to pursue further studies by integrating horseshoe crabs into them?
That'll be interesting for them to take on. Yes, I believe so. Right. All right. So, Doctor, we have come to the end. Before we finish, I'll do a short summary of the talk today. So, horseshoe crabs in general, they are visible during full moon. They are not actually classified as crabs. There are only four species known worldwide, three which is occurring in Asia. Beach condition is very important for the embryogenesis, is for the development of the embryo. And then fishermen, they feel inferior, even though they are very well appreciated for the efforts. They have local knowledge, which is very important for the conservation of these horseshoe crabs. Right. So next is it's important to communicate these issues and to conserve the environment. That means issues facing the conservation, the ecology of and the habitat of the horseshoe crabs. And coastal development is very much affecting, it's severely devastating the conditions where horseshoe crabs thrive. And lastly, community-led programs are very important to the success of the conservation efforts of these horseshoe crabs. Right. So with that, Doctor, we thank you very much for your time today, for sharing your knowledge, for sharing your information. We hope that we can take this further on as a partnership with MNS and so forth. So we have a lot of conservation activities going on, and we hope that you can join us. We hope the rest of you who is listening in, we hope that you are joining us as well in our efforts for conservation. Right. With that, we thank you very much. Enjoy your weekend.
Mr. Wuti. Thank you very much for today.